Hello?
Blaize, how are you today?
Yeah. Good. How about you?
Good, good. Thanks for asking. All good here in my world. I'm not at the beach. I wish I
So,
was. What's going on in math?
like in class, I don't have like a thing to send you, but in class, we're basically going over like fifth grade, like mean, median, and mode. So I don't really see a
Yes.
point in doing that. I mean, we can, but
Let me give you a few kind of the exception questions if you'd like, or we can move on to something else.
yeah, mean, median, mode, range, whatever, you know, like the whole, like the thing.
Yes.
Yeah.
Okay. Do you know if you guys will be doing box plots?
Oh, we're doing line plot, bar graph, and what's the one, like the whisker chart? What is it called?
Yeah, that's box and
Not box plot.
whisker.
Yeah.
That's the one to kind of look at. Okay. Let me give you some questions in this area, and then we'll get started. Or we'll get started now doing that. Anything else you want to cover?
And I mean, I don't necessarily need to because I know how to do it, but we could also do like cube root functions and square root functions.
Okay,
I basically know how to do them, but
got it. Okay, yeah, that's enough. And were you guys using a calculator today in class?
yeah.
All right, very good. Okay, so let me share my screen, and actually it's already shared. Okay, here we go. So let's say I give you a data set 5, 9, 3, 1, 4, and 12. Okay. They probably mentioned this class. The first thing to do is to put them in order.
Yeah.
So this is 1, 3, 4, 5, 9, and 12. Okay. You then need to count the numbers. How many basically? Not the total, but just how many, right? So there's six numbers here. The median is the middle number. Do you have a middle number here? So with evens, you don't. You have two middle numbers.
You add them and then divide them by 2.
That's right. Okay. Okay, so that's the first thing to think about when it comes to median, is that if you don't have a middle number, it's this. Okay. Any questions on that?
No.
All right. Let me add a number to this data set. And let me add another number to this data set. What is the mode?
1.
Is there another mode?
5.
There could be more than one mode. More than one mode. Okay. Now let's say I give you a new data set that's just like this. Does this have a mode?
No.
No mode. Good. Okay. Very good. So now we can move on to box and whisker plots. So I got to go find a quick data set for these. I like how you put that 5th grade math. It's really, it is. It seems like, why are we doing this? But that's yeah, sometimes you don't know. All right, so here's a new data set. I'd like you to find the median of this data set for us first.
So 11, 12, 13, 14. Uh, 14. Yes.
Okay, so you say the median is 14, and I heard that you're putting this in order, which is really good to do. I know it's a little harder when you got to look at it on a screen. I'm going to do the same. We can't do it without that. There's another 14, 16, 18. How many numbers do you have here?
None.
Right. Okay, so there's truly a middle number. Okay. Now, the next thing for a box and whisker plot is you need what's called quartile 1. So when there is a single middle number, you then look at the left grouping and then the right grouping. The left grouping will give you quartile 1. You have to look at what is the median of this data
12.
set here. All right, so that's Q1. And then and then Q3 comes from this one on the right, that's kind of this upper.
14.
Well, there's two middle numbers.
Oh.
So
Oh.
on the one on the left, you add them up and divide by 2. It's the same. Here you got to add them up and divide by 2, the two middle numbers.
Oh wait, that's 20. That's 10.
Can't be smaller than this number. It has to be between 14 and 16. You're finding the average of 14 and
Oh, I
16.
forgot. Yeah, you're right. Wait, isn't 14 plus 6 15?
Yes,
Right?
yes,
Yeah.
yes. Very good. Okay. Now, the next thing to do, and this is where it gets a little bit more complicated, is you have to find what's called the interquartile range. For short, we will call it IQR because I don't want to write it, and I doubt you do either. IQR is Q3 minus Q1. 15 minus 12, which equals 3. So this is all the build up to like actually getting the box plot. You need a bunch of things here each time. Then you need what's called the upper fence. The upper fence is quartile 3 plus 1.5 times the IQR. Quartile 3 is 15. The IQR is 3. This becomes 19.5. Any questions on that? Just using that formula?
No.
Okay. There's also this thing called a lower fence. Lower fence is Q1 minus 1.5 times IQR. Sorry, I would say I times Q, IQR. So that's 12 minus 1.5 times 2. That's 9. Okay. So now the reason you have this upper fence and lower fence, I'm going to grab the data set one more time. Actually, let me snip it into the other screen. You're looking to see if any values are, here's the lower fence at 9, the upper fence at 19.5. Are there any data values that fall outside of this range?
No.
No. So so if they did, and this one does not, if they did, it would be considered an outlier, which you don't have, but you would consider it an outlier. Okay. So now we go back to our Q1 meeting Q3. We need the min and the max to close this out. The min is 11 and the max is 18. So we need these 5 numbers to draw a box plot. All right, so you start with the median. I'm just going to call that 14 right there arbitrarily. That's the median. You draw a little vertical line. Consider each of these boxes on my screen to be 1. So Q3 is 15. And then Q1 is 12. And then the min is 11. That's the whisker right there. And then the max is 18. There's another whisker for that. So this is your box plot. So it's a box, a rectangle, and some whiskers. If there were outliers, we would deal with that later, but there are none, so we don't have to worry about that. Any questions on that?
No.
All right, just looking for another data set here that we can use. Looking for one that's a little bit different. 1, 2, 3. There's all have 9 in it. Why do they all have 9? Okay, let me find another problem here. One, 2, 3, 4, 5, 6, 7. Okay. All right, here's another data set here for us to look at. Maybe do one more of these and then switch to some root stuff. Okay, go ahead and put the data in order for me, and then find the median here, please.
Is that okay? No.
Yeah, sorry, that's just a fragment from my snip.
63. 5, 112, 117. The median. Oh, 1, 2, 3. 85 is the median.
I agree. So if we put these in order, 63, 68, 77, 85, 99, 112, and 117. Okay, so the median is definitely 85. Now, for Q1, you have to circle the lower group and the upper group for Q3. This time, though, there is an exact median in here.
Oh, so Q1 is 68 and Q3 is 112.
Yes, exactly. Right. So the this is good. This helps us with figuring out some of this other stuff. So the next thing is to determine the interquartile range. That's Q3 minus Q1. Can you calculate that for us, please?
Okay. Get a calculator. $44.
No. Try again. Sorry, 44. 112 minus 68 is
Yeah, that's what I
44.
said.
Okay, I misunderstood.
Oh.
Okay, so what you're looking for now are the outliers. Okay, and you may not have any of these. We're going to skip that for this problem because I'm not sure it's going to be super helpful to keep looking for outliers when there aren't any. But that's why you calculate the interquartile range. The next thing you need is the min and the max. That's why you put these in order so that you can quickly find that 63, 117. And so to graph this, you again kind of start with the median. You just pick a place arbitrarily and say, all right, that's 85. Okay. And just for the scale of the numbers, I guess I'm going to go by 10 each grid roughly. So that would be like 95, 105, and then right there, we'll call that like 112 for the Q3. I tend to go right first for whatever reason. Couldn't tell you why. And then you got to go left for Q1. So each grid is 1 or 10. So it's 75. That's 65. So it's, we'll say there-ish. That's 68 for Q1. And then the min, you go out where you need to go. It's roughly there for 63. For the max, 117 is probably right about there. Something like that. So there's some other questions that we can look at too, to interpret box plots. Let's see if I can find one of those. Yeah, this is something you might see on a test or quiz. Sometimes they give you one to make and then the other one is like to interpret here. All right, so they've given you the box plot here. And they're asking you for the highest score on the test. What's the biggest number in this data set? I know you don't have it, but you have the box plot, which includes the max and the min. 102, yeah. Now to answer the next question, I have to give you a little bit of information that we hadn't talked about yet. If I look at, I guess I should highlight it. This right here, each of these like regions is 25%.
Yeah.
Even though they're not the same width, they're all 25% of the data. So when it says what percent of the class scored above a 72, you have to say, oh, it's 25 plus 25 plus 25.
75.
75%, yeah. All right, how about the median score of the test?
72. No, I know. 88.
88, so that's the middle one. And then what percent of the class scored between 88 and 96?
25%.
25%, yeah. Okay, very good. So not too bad, something that you could do here. So the other type of problem they might ask you is to compare two box and whisker plots. Okay, and here's a pair of box and whisker plots. The top one is time spent on homework each night. Bottom one is TV time. We could probably replace that with time on a cell phone. So you could be asked some questions like, which group has a higher median?
TV time.
Yes, right. 60 versus 48. Okay. Which has a smaller min?
They're the same.
They're the same. So both are the same. Fantastic. Okay. Here's some, let me grab a few questions that they have written here. And we'll do a couple of square root problems. Actually, you're going to need to see this. All right. What is the third quartile for the TV time data?
110.
So it's, yes, exactly. Yes. I was going to say, I didn't know if we covered that, but that's really good. All right. So good stuff on that. And you're right. I mean, it's pretty basic stuff. There's not really a lot of hard math calculations, not very mathy. Here's just kind of a starter problem on square roots, something totally different. Do you remember anything about how to reduce something like this?
Do you? Oh, you put it the entire thing to the power of 2 to remove the square root, right?
Well, you're essentially taking the square root of each of them. Or you can look at the square root of the square root really is to the power of 1/2. Maybe that helps. I'm just trying to see where to start. How much of this don't know, remember.
A lot of like the questions are like square root functions. So like f of x.
Okay, so you're
square root
not
of
actually
x plus-
simplifying. Okay, so
Yeah, it's like f of x equals square root of x plus 3, for example.
Okay, got it. All right, let's just start with the square root of x. This is called the parent function. And the reason is like everything else kind of looked like it. It's like you kind of look like your parents. You share some of their traits, qualities, physical features, all that stuff. There are only certain values that you can take the square root of. Like you can take the square root of 0. The square root of 0 is what value?
1, or is it 0?
It's 0.
Oh.
How about the square? How about 1? What is the square root of 1?
1.
Okay. What's the next square root that you can consider? Like, can you take this?
2.
Yeah, 4. Square root of 4 is 2. And what's 1 after that? One more.
6.
Square root of 6 is unknown. Because you would need 2. 9. Yes.
4.
Very good. So this parent function you have to know in this table. Like you have to roll out of bed and be like, square root of x, 0, 1, 4, 9, 0, 1, 2, 3. Or get there, pretty quickly. So like you said, f of x is the square root of x plus 3. Okay. There's a couple of ways to do this. One is to look at transformations. Did you guys talk
Yeah.
about that?
Yeah, isn't it like up 3 or something? Yeah, that's what.
So that when it's inside the function, it's either left or right. This one is actually left 3. Left 3. If there were a plus 2 out here, it would be up 2. So does left and right, that affects the x?
What?
So we're going to take our table. So our original table was 0, 1, 4, and 9, and that became 0, 1, 2, and 3. Now we're going to transform this by moving all the x values left 3. Left 3 means to subtract 3. So I want you to subtract 3 from each of these x values.
All right. So 6, 1, -2, -3.
You're subtracting 3 from the x values only.
Yeah.
Oh, I'm sorry. You started at the bottom. Okay.
Yeah.
I was like, they weren't making sense. And then the y values stay the same. Is that okay? Clear?
Yeah.
Okay. So now let's look at another transformation. Let's say we'll start with 0, 1, 4, 9, 0, 1, 2, 3. And let's say your f of x is now the square root of x minus 5. When it's outside the function, it's up or down. Do you remember if this moves it up or down?
Oh, it's down.
Down.
5.
So this is down 5. Down affects the y value. So every y value, f of x is really y, is going to go down by 5. What are the new y values?
Wait. So -5, -4, -1, and 3. Wait. No.
Subtracting 5.
Wait,
Yeah,
no,
2
no,
minus 5.
4.
Yes. I'm sorry.
Not negative. +4.
So the last one here is 2 minus 5 and then 3 minus 5.
Wait.
I mean, you said every y value you're subtracting by 5. 0 minus 5, definitely minus 5. 1 minus 5, definitely minus 4. 2 minus 5 is minus 3. 3 minus 5 is minus 2.
Oh,
Okay. So now these can also be paired up together. So let's say, again, I'll give you the parent function here. 0, 1, 4, 9, 0, 1, 2, and 3. And let's say f of x is the square root of x plus 2 minus 3. So this has two transformations. Inside parentheses means left or right. This is left 2. And then down 3. So the left 2 affects the x value. You're subtracting 2 from each x value. Down 3 means you're subtracting 3 from each y value. Can you give me the new ordered pair for the first one? Going left 2 on 0 and down 3 on 0.
Left 2, so it'd be -2.
Okay,
And then -3.
good.
Okay, yeah. -1, -2.
Good.
So 2, -1. 9, 7, 0.
Very good. Okay, and these are kind of more what you're seeing in class, something like this.
We're more of doing just like translations, but this was a while ago.
Okay, Main thing
Oh.
is to remember that parent function. That will definitely be your source of being able to do most of these problems, but that's going to do